Students, let us understand a very important concept of vector space, which is linear combination and linear span. It is the easiest topic, very scoring topic, and you will like it because there will be something numerical sort of thing which you have already done earlier. Okay, so now let us first understand what is the meaning of linear combination. What is a linear combination? Suppose if VF is a vector space and alpha 1, alpha 2, alpha 3, alpha n, they all belongs to V. Okay? Same way, A1, A2, A3, An all belongs to the field F, as B is defined on field F, right? Then the combination like this, A1 alpha 1 plus A2 alpha 2, that is A1 alpha 1 plus A2 alpha 2 plus A3 alpha 3, An alpha n is called linear combination. Correct? This is called linear combination. We can also write it like this, summation of ai alpha I for I is equal to 1 to n. So this is called the linear combination. Right? Now, understand what is linear span. Linear span is represented like LS. Okay? Now, how I can define linear span? Suppose if VF is a vector space, okay, and SB any non-empty subset of V, then the set of all linear combinations, of finite set of elements of S is called linear span of S, which is denoted by LS. So basically VF is a vector space and S is any non-empty subset of V. I am writing down the linear combination of elements of S. So set of or the collection of all the linear combination is known as LS. So mathematically I can write LS is equal to A1 alpha 1 plus A2 alpha 2 An alpha n, such that alpha 1, alpha 2 all belongs to S. Okay, S. Remember this thing. Okay, this LS is also known as subspace, span, or generated by S. We will study this linear combination as linearly dependent and independent, and also this generated concept in the next topic. Right now in this video I will just teach you how to check that how to write the span and how to check whether an element belong to LS or not. Okay, linear span or not. So let us start with the first question. My first question says that find span of S of V2 and prove that 3, 7 belongs to LS. So first step, you need to write down the linear combination. So what is LS? LS is basically set of all finite linear combination of elements of S. Correct? So how I can write down here? I can write down here as, so now if A and B belongs to F, okay, then how you can write down the linear combination? Linear combination will be equal to A 1 comma 2, or I can here I'll write A alpha plus B alpha 1 plus B alpha 2. So A alpha 1 means the first element of S. So 1 comma 2 plus B. What is the second element? 0 comma 1. So this is a linear combination, or you can say this defines the span. Now this is defining the span for different values of A and B. Correct? Now what is the concept? If you can find out A and B, for any element, means that element belong to span, otherwise it does not belong to span. So now let us check for 3 comma 7. So if I can write 3 comma 7 in this combination, then it is into linear span, otherwise it is not. Okay, so let me solve this. 3 comma 7 is equal to, how to solve this? What is the first element here? A. What is the first element here? 0, comma. What is the second element? 2a plus b. Okay, so two ordered pair are equal if first coordinate is equal to first coordinate, second coordinate is equal to second coordinate. So a is equal to 3 and 2a plus b is equal to 7. So if a is equal to 3, so b is equal to 1. So I am able to find out the value of a and b. So I can express 3 comma 7 as 3 1 comma 2 plus 1 0 comma 1. You can solve and check. Implies 3 comma 7 belongs to linear span. Simple. Now let's do the next question. Now find the linear span of this and show that 3 comma 7 does not belong to the span. So now how I will start this? Again, what is the linear combination? A 1 comma 2. So LS I am defining like this, plus B 2 comma 4. So this is my linear span. Now I want to check whether 3 comma 7 belongs to this or not. So 3 comma 7 is equal to A 1 comma 2 plus B 2 comma 4. So this is 3 comma 7 is equal to, first element is what? A. First element is what? 2B, comma 2A plus 4B. Now two ordered pair are equal if first is equal, second is equal. So A plus 2B is equal to 3 and 2A plus 4B is equal to 7. So now solve these two equations. You can use your calculator, or since it is two variable, easily you can solve. So if I multiply first equation by 2, so 2A plus 4B is equal to 6, 2A plus 4B is equal to 7. Subtract both the equation, what you are getting? 0 is equal to minus 1. Does it make any sense? No. Means at any cost I can't express 3 comma 7 as a combination of 1 comma 2 and 2 comma 4. Implies 3 comma 7 does not belong to LS. Easy. Now let's move to the next question. Now see, now I have to show that this number does not belong to span of this. So what I'll do, first step, I'll write down the linear span. So what is the linear span? A 1 minus 3 comma 2 plus B 2 minus 4 minus 1 plus C 1 minus 5 7. Right? So this is a linear span. Now I want to prove that this does not belong to linear span. So I will try to write down this as a linear combination. So what is the first term? A plus 2B plus C, comma minus 3A minus 4B minus 5C, comma 2A minus B plus 7C. Correct? So both sides I have triodes. So first element is equal to first element, means A plus 2B plus C is equal to 2. Minus 3A minus 4B minus 5C is equal to minus 5. 2A minus B plus 7C is equal to 3. Now you have the calculator. Put these three equations in your calculator. Go to mode. Select simultaneous equations. In that, select three variables. Put the values and you will observe that you will get no solution. Okay. If you use the latest calculator, it will show no solution. If you use the very old model, it will show math error. Right? So the moment you see no solution, you can say that I cannot express 2 minus 5 3 as a linear combination of these three vectors. So it does not belong to linear span. Now if you don't want to solve it by calculator, then what is the other way? The other way, which you have already learned earlier, express it as a augmented matrix A dot B. If you have any doubt on this system of equation concept, there are videos for system of equation under linear algebra that you can access and you can understand the basic concept of system of equation. So 1, 2, 1, 2, minus 3, minus 4, minus 5, minus 5, 2, minus 1, 7, 3. Now what I will do, I will reduce this matrix to the echelon form. And what is the concept? Using this one, make these two numbers 0. So what operation I can apply? In R2 I can apply R2 plus 3R1, and in R3 I can apply R3 minus 2r1. Correct? When you do this, you will get 1 2 1 2 0 2 minus 2 1 0 minus 5 5 minus 1. Those who don't know the concept, please go through the video of system of equation. You will understand it clearly. Right? Now make this number as 1. So 1 2 1 2 0 1 minus 1 1 by 2. So basically I am trying to reduce it to echelon form. Now third row divide by 5. So I'll get minus 1 1 and 1 by 5. Correct? Now using this number, make this number 0. So you will get the structure 1 2 1, which is echelon form, perfect echelon form. 0 1 minus 1 1 by 2 0 0 0 3 by 10. Correct? Now when you observe, this is matrix A. So rank of A is what? How many non-zero rows are here? 1 2 2. Now if you observe the whole matrix, which is the augmented matrix, rank of A dot B is how many non-zero rows are there? 1 2 3 is 3. The moment the ranks are not equal, we say no solution. So this system of equation has no solution. Now in exam, you can go by this method also. No problem, you can very well write this system of equation has no solution, so linear combination not possible. But check with your calculator. Or you can go by the rank concept. Both are same. No need to do both. Only one you have to do. Whatever you like, you feel it is easy, that you do. Now show that 2 2 3 is in span of S. Now how to do this? Again, first you write down span. Span is A 2 1 4 plus B 1 minus 1 3 plus C 3 2 5. Now I need to check whether this belongs or not. So 2 2 3 is equal to 2A plus B plus 3C, comma A minus B plus 2C, comma 4A plus 3B plus 5C. Right? So 2A plus B plus 3C is equal to 2. A minus B plus 2C is equal to 2. 4A plus 3B plus 5C is equal to 3. Now what you do? Take out your calculator and solve these three equations. Okay, pause the video, take out your calculator, just don't write down the answer and solve it yourself. You will observe A is equal to 1 by 2, B is equal to minus 1 by 2 and C is equal to 1 by 2. If you don't know how to use the calculator, there are videos to use calculator I have done for various models, so you can go through it. So I can say that 2, 2, 3 can be written like 1 by 2 of 2, 1, 4 minus 1 by 2 of 1 minus 1, 3 plus 1 by 2, 3, 2, 5. So it belongs to linear span because I can write it as a linear combination. Okay. Let's see one more question. Again, what is your linear span? Linear span is equal to A 3, 0 minus 2 plus B 1 minus 1, 3 plus C 2 minus 1 minus 5. Correct? So now I need to check whether this belongs to it or not. So 1 minus 2 minus 8 is equal to, what is the first term? 3A plus B plus 2C, comma 0 minus B minus C, comma minus 2A plus 3B minus 5C. Correct? So what are the equations? 3A plus B plus 2C is 1. Minus B minus C is equal to minus 2 and minus 2A plus 3B minus 5C is equal to minus 8. Now solve these three equations. When you solve these three equations, you will get A is equal to minus 1, B is equal to 0 and C is equal to 2. So I can write this number, this vector as a linear combination of these three vectors. So it belongs to a linear span. Correct? So here also you can use the rank method. You find out the rank. Rank of A will be equal to rank of augmented matrix. But it is lengthy, so I will not suggest you to use that method. You directly do by this. Solve the equation. You have calculators. Get the answer. Okay. Now you can try these two questions. Once you have to check that this belongs to linear span and then you have to check whether this belongs to linear span. I hope you understood the concept. It is a very easy and simple concept. In next video, we will discuss about linearly dependent and independent variable vectors, and then we will discuss what exactly is basis. I hope you understood, and if you have any doubt, let me know. Subscribe the channel, share the channel, and encourage me as you are doing always. Thank you.